Yeah, hello. So as till now, what has been discussed there in the demo, as about like Satya sir told us like the scenario how protocol development and testing training is being processed. The first thing that you need to understand the technology part. The second thing that we are covering the development and then further testing, and finally we are going to deploy that particular code over there. So how this process is working in practical scenario. When we are talking about the practical, there is a practical about like development where you will done a programming on C and data structure. So that is the advanced C. Once the programming of C and data structure is complete, then we are moving towards the IPC or like your Unix programming. Okay, so Unix is very essential here because the development currently in the industry is going towards the Linux environment. So everyone is using Linux for code development, for protocol testing, for deployment, even like your SDN, NFV, every these cloud scenario also working towards the Linux environment. So that is very important. So once development is done, then to test this development part, we are having a Python code. That Python code we are using for initiating the particular test scenario, the test cases, like what protocol that you want to test. If you have developed a MAC layer protocol that you need to test through the Python code, and there I'm having a complete network simulator is built up here. Okay, so let we proceed how this is work around. Like the first is the development, and once we need a development, we need to follow some standards also, because that is one of the industry level development that we need to do. What exactly is the protocol that we are understanding, what like the specifications we are going through, sir told us like we are having different specification 14, 15, 16. So whatever the specification they are provided by 3GPP, or based on those specification only we are collecting all the information, and then we are developing the code. So if I just open, suppose there is release 36 is there, so release 14, this is one of the release 16, and the 3GPP specification is provided is 36.331. This is of release 16 specification, very specific for like RRC development. What exactly is radio resource control, connectivity with EUTRON with their technical specifications, protocol specifications that is provided here in this particular document. So in this document, every step of RRC protocol is defined, like how UE is communicate to EUTRON using the RRC connection. Okay, so what are the requirement acquisitions, MIBs are going to be shared, like SIBs and MIBs are containing different interfaces. There is specific particular values, informations that going to be shared in between Neutron and UE. So how we initiate this particular connectivity, what are the requirement for this, what structure that we need to follow to forward the messages there. So everything is defined in the document. So this is one of the document of series 16. If we are talking about series 15, so there is the different document. So once we come to the secondary document, and here we are having the series 15. So 3GPP TS 38. So series 15 is having 38.331. This is one of the specification. This also initiated for technical specification radio access network for the NR to be initiated with RRC. Okay, so once you are going to cover the code or the protocol or the interface for the RRC to NR in specialization, you have to follow this particular series 15 document, in which we have defined the architecture, their particular procedures, what the procedures that we need to write, every procedure in a very specific format, their communication, their message type, their includes values, everything is defined here in the document. So we have to, as a developer, first follow these requirements, first understand the these particular procedures, specifications, and then we move towards the development. Now once we are going to develop the standard code there. So we have to follow some standard procedure written by the 3GPP specification team, and there it provided as ASN format. So ASN is what? ASN.1 is one of the notation, that object notation, that is very specific coding that has been defined for standard network level protocols. Okay, so that ASN.1 is an essential ingredient for achieving the script speed requirement defined by ITU, as well as this is combined by 3GPP and ETSI, both to have a particular specification initiated objects that we need to write in the code. If I'm writing this particular code in C, so I need to follow the particular header files that has been defined by 3GPP. There is respective like objects, their respective like particular you can say like structures, though whatever the message you have to transfer. So everything that has been defined in the ASN format. Okay, so come to the development part. Here you can see the program. So a C program can contain a different their particular bodies, starting with a very specific like their preprocessor unit and the header files. So what header file I need to utilize, that based on what exactly I am going to do. Suppose a normal standard initialization, I'm having standard input output. Then we are initiating here multiple threads. Threads are basically the child processes, and that is kind of child processes that is having a shared memory. Means if you want to execute a complete process into multiple their child processes, but not initiating their individual memories, you want to run them all to be work with one shared memory of the process. That time we are initiating thread that increase our productivity, the processor speed, processor execution. Okay, that's why we are moving towards the thread environment, and multi-thread we are using here for different protocols. So we are having a list of protocol what we initiate through a single process. We launch all multiple threads there. So for thread we are using their particular p thread, process thread, to be initiate over there their respective semaphore, so that we can have like the protocol initiated value to be transferred in between these protocols, as well as like we are having the socket initialization, because whenever we are connecting UE to network, the physical layer to be connect as a socket here. So respective header files we have to utilize here, and through these header files we will initiate our code for a very specific protocol. Suppose you are working on RRC, you have to use the header file for the RRC. For RRC, for MAC, for PDCP, their respective like functions, header files you have to call here. Okay, so once you are calling the header file, then you need to define some functions. There is specific function to be retrieved here, and you have to write their respective informations. Like I'm going to write a code for RRC. So once I'm having the RRC, so RRC is particular containing multiple structures there. Identity request structure, RRC setup request I. So similarly, we are having initial UE identity. So these different structure we have to define, and then we need to call them in our particular thread function. So we are having different functions for different protocols. So here we are starting the RRC. So RRC, once we initiate, we have to write their particular message queue. Message queue is the collection of like all the packet coming from the physical layer. So it collect inside the message queue, and one by one it will like execute here. So we have to decode the message, retrieve the requirement of the network, retrieve the requirement of the UE, and then execute here and process accordingly. Suppose I'm getting RRC request, connection request, that is from the UE to network. So whenever network get on the RRC protocol a RRC connection request kind of message, it need to decode that particular message. It need to like then provide a parameter for setup. Okay, so for connection setup here, the connection setup parameters will be initiate here and transfer further back towards the UE using your physical layer. And here with the physical layer we are running as a socket. Okay, so here you can see RRC connection setup is generated, and then connection setup is forwarded towards the network. So once I completely initiate my function, once my RRC protocol is up and ready for deployment, so I need to first test this, whether the parameters I'm passing towards the RRC, that is correct parameter or wrong parameter. In the both end, how RRC or how network layer is initiating, how network layer is responding. So although there are known bugs, we have to check, like if any wrong parameter is passed, how that then network will be revert back, or if I'm passing a perfect parameter over there for the network, then how my network is reverted back to me. So these things that we will check with some parameterized value, and that we will initiate through the Python code. So for that, we are having user node written in Python, and this is what we are named this as a network simulator. So once I open this as a code, so here in this code, we have defined the socket connectivity towards the network. So we define the IP address and the port where my network functions or network threads are running. Then I initiate a particular simulated environment over here that is known as NEXP5 network simulator, in which we are working on release 15. We can work on 14 also, 16 also. As per the release, we have to change our parameterized value. So here we check the protocols, what protocol we want to test. So we initiate the test for multiple protocols: RRC, RLC, MAC, PDCP, NAS. These all protocols we defined here to test. For the testing, we have initiate their respective functions here in Python. So suppose for RRC, once we initiate RRC, there is one code written over here. What message that UE simulator need to send to network? As initially a packet is containing header part and the body part. So we have to configure the header. What exactly is we are sending in header, who is the source, who is the destination, what kind of protocol we are retrieving here, and on that protocol, what kind of message we are trying to execute. So that everything we will define in our header part. And then once header is generated, then the body part. In the body, we define what kind of procedure we want to initiate, whether that is initiating the protocol setup request or setup complete or UE message, S1 AP message, whatever the message requiring over there, we select that appropriate value, and then finally we pass this value to the network. So when we are sending the value to the network, we are combining the all value in one string. So there will be a multiple scenario that UE defined. So we define the value for the UE as a particular sender. Then who will be getting, or the destination is suppose E node B. So we define here the destination, who is going to select or who is going to get this particular message. So we define the destination over there. Then after the destination, we select the protocol type. So here we select RRC is the protocol. So we define the value for the protocol. Then we select whatever the message we are transferring, RRC connection request and its value. So reflective with the request format, what exactly is the RRC connection request message type, there is specific value there. So we define the value. Then we define what the value is being sent, what is the initial UE identity choice, and what is the establishment cost value. So these all value we print together and find one string and forward the string to the network. Okay, so let we just run these code. So for that, we are having a Linux environment. In the Linux environment, one hand I am having a C code, gnodeb.c, and on other hand I am having ue.py. So first let me launch the network. So to launch this network, I have already compiled this code, and the compilation node is GNB. So GNB, once I launch this, so it initiate all the threads. Here I am having RRC thread, PDCP thread, SDAP thread, RLC thread, MAC thread, and physical downlink thread. These are the threads has been initiated. Okay, so once a thread is initiated, means now network is active to get the message from simulator, that is UE simulator. So on the other hand, I need to launch the UE. So as soon as I launch the UE, a socket is initiated. That is my physical layer connectivity in between UE and network. So EUTRON, or you can say the G node B, is going to be connect with UE using this particular socket where address has been defined. This is the address for UE and this is the address for network. So on top of these network, the packet is going to be transferred. Now I am having a simulated environment where it says like you have to select any one test case. What test case you want to select? RRC, RLC, MAC, PDCP, NAS. So here, suppose in the previous example, in the C code, I told you like how to write the RRC code. If we have done the RRC development, now we need to test this RRC. So for testing the RRC, I have already defined all the value or the parameter that UE need to send to the network. So once I select this, I select number one. Number one is what? My RRC protocol. Once I select this, automatically it send all defined value to the network. So you can see here on the selection of one, RRC test is initiated. And then it initiate the sending data to network. So what data RRC UE is sending to the network? The first is source is UE and value is 1. It means who is sending the packet to the network is UE. Okay, the destination is G node B. The second is what is the destination? That is G node B. Then protocol type. So what protocol the product is initiating is RRC. Then in RRC, what kind of message we are generating? That is RRC connection request. So the complete length of the packet is now 5. It's based on the previous connectivities. Then come to the main body where we initiate the value, that is initial UE identity choice and establishment cause for MO signaling. So that particular value we have feed here. So once we collect all these values, the header and the body part, then my combination is of 1, 2, 1, 1, 5, 6, 1, 3, 0. And that you can see in a string format, that is 121156130. This is what? This is a packet, a combined packet which need to send from UE to network. In ideal way or in the real environment, this message is going to be encrypted. So if you are analyzing the packet, you will not get any name there, protocol name, because these messages are encrypted messages on the physical layer. Here we are decoding this as a 9-byte of the string, and this 9-byte string then further forward to the network, and on the network end we can check what we have received. So after the physical layer initialization, a socket is generated. This socket is initiated, and after the socket initiated, the value the network get is 121156130. This is the same string what has been passed from the UE. Okay, there you can see a G node B physical layer forward this message to respective protocol layer, and that is RRC. So RRC get the message and now try to decode this. So once a message string is there, RRC is going to decode. It got the source is UE and destination is G node B. So once it got the source, destination, protocol type and message type, then it authenticate. Okay, this is a authenticated message, and now I can process with the body part. Then we initiate the body, and number of the significant bit is 6. They are identical, like initial UE identity choice is NG5GH TIMC part 1. The random value is 1 and spare of the RRC is 0. So once this message is received to the RRC, then it initiate the setup, sending RRC connection setup. So it generate the RRC connection setup, and then it send this information to the network. Through the network, it's going to be forward to UE. So this is how our testing part initiate. If you want to trace the value, what exactly is being transferred in between UE and RRC. So for that, we are having Wireshark. So I can open here. So once I'm having a RRC, oh sorry, Wireshark is up and running, there I can initiate packet session. And once, and then I start here again. Suppose I'm having a choice of the network again to be select. So my network is up and ready, and my UE is initiated here. I send 1, and my message is transferred to network. Now we can verify it through Wireshark. Let me stop it and search for a particular port of my socket. So here on this protocol, I'm initiated with the socket port is 9999. So let me just search this 9999 port. So here you can see a message is being transferred. The source port is 934112 and destination port is 9999. 34112 is the source and destination is 9999. Let me just check and verify. So my source is localhost 34116 is the my like particular port, and 9999 is my destination. Okay, so once I hear and check the message, so what I will like get is the particular data is going to be initiated. This is my transmission protocol. And I'm having a data of 9 byte. Let me check the data, and here on the bottom I'm having the particular data 121156.130. This is the particular data 121156.130. A data which already we have seen here is going to be sent from UE to the network is the same. That is 121156.130 is sending from UE and received at network end, that is 121156.130. So here we can verify it using Wireshark, the same packet that is going to be sent from the like particular 34116, that is the source port of UE, to the 9999, that is destination port of network, to be sent a 9 byte information. Okay, so that development and testing. After the development and testing, there is a choice like whether you want to go to deploy the particular protocol or the software on a real device, or you are going to deploy through the telco cloud. Because now we are working on the 5G environment, and it's going to be deployed everywhere. There is one of the property of 5G, we are working on network slicing environment. Okay, so that require one specific potential of the network, that is virtualization. A network virtualization is very necessary here. So once we are moving towards the telco cloud, cloud is also is a virtualization environment. There you are going to virtualize the network functions. So when we are talking about network function, what is the network function? So we are having different scenarios, like if I open a normal architecture of EPC. So in the EPC, we are having different interfaces to their respective functions. We are having MME, HSS, S gateway, P gateway, PCRF. So where MME, SSS, PCRF, these are the control layer of the message forwarding, and S gateway, P gateway is forwarding the data plane, user data plane. The main packet is going to be forward over there, and their respective interfaces. S1 interface is there, which is S1C, S1U interface. Then S11 interface is there, S6A interface, S5, S10, and GX interface are there. So how these interfaces, how these virtual machines, or sorry, these network functions are going to be functionalized. So when we are talking about MME, HSS, S gateway, P gateway, PCR, these are the network functions. Those are currently running on dedicated hardware and dedicated servers. The problem of the dedicated hardware and dedicated servers are they're not too much flexible. The first thing, the first limitation of the traditional or legacy hardware in the telecom network is these devices are not much dynamic. As we know, current network scenario is too much dynamic and need to be agile every time. So as per the requirement, we have to scale up and scale down our network. Once we are moving towards the scale up and scale down to the network, the problem is there, like the current device are box pack environment or the hardware based environment that not allow us a a fraction of, or you can say dynamic scaling up and scaling down. The second thing, though these are the hardware environment, everything is defined from a specific vendor. So these are proprietary or vendor specific devices. So vendor dependencies are there. For any kind of changes, for any kind of upgradation to the network functions, we have to rely on vendor. When vendor will provide the functions or upgrade or update scenarios or any security you can say the softwares there, that time only when vendor provide these things, then only we will be able to deploy it on real network. Otherwise we have to wait for the next release, or we have to upgrade our devices, networking devices. So that upgrading the networking devices and deploying the networking devices will always increase our capex and opex. So these are initial restrictions, or you can say dependencies of the traditional network, though that need to be handled during the 5G deployment, because 5G is need to be more dynamic, more agile, and more sensitive network deployment over there. That increase the productivity, that increase like the dynamicity over there, as well as we need to decrease the capex and opex. So the solution here is a software defined network as well as network function virtualization. A software defined network means SDN. SDN is one of a newly initiated network management technology, or you can say the architecture that initiate the abstraction in between the hardware and their functionality. The abstraction in a hardware and functionality let you manage more frequently the network functionalities, their dynamicity environment. Like if you need to scale up, scale down, if you need to manage the configuration, if you need to rechange the configuration, routing protocols, anything there in the network, that will be more easy to deploy over there. As well as this provide you a centralized location of network administration, and that is known as SDN controller. So using SDN controller from a centralized location, you can manage not only a single device, but a complete topology. And once you add this in a WAN environment, that is your SD-WAN, means from a single location, you can manage end-to-end network deployment. So for these network deployment, we have to utilize the network functions to be on board on a cloud. And cloud is what? Is our OpenStack. So here, if I just show you, this is one of my cloud scenario. In this cloud, I'm having virtual instance, virtual CPU, virtual memory, virtual RAM, virtual network. And once I'm having this end-to-end functions, I can utilize this to deploy my network. So how we are using this complete like a cloud scenario? For that, we are having the functions Suppose I need to generate one network that is of EPC. Take example, I have to deploy this on telco cloud on a network, because I need to more optimize my network. I need to reduce the hardware costing, as well as I need to make my network to be agile. So for that, I'm going to deploy this EPC on top of my cloud. For that, I need to first check whether I'm having all respective network or not. Suppose interfaces. So defined interface here is S11 interface, S6A interface, S5 interface, GX interface. So for that, we define S6A, S11, GX, S5, these interfaces here. On top of these interfaces, now I need to deploy a complete EPC. So for that, we are having the YAML script, or you can say some Tosca templates, network cloud templates. So we have to design those cloud templates. Suppose here I have defined my EPC template, in which I define all like their component MME, HSS, S gateway, P gateway, PCRF, and their respective interfaces. S11 interface, S6A interface, S5 interface, GX interface, and they all are working on Linux operating system and router operating system. Okay, so once I define these everything here, then my role is to just deploy it on my cloud. So here, virtual EPC VNF, I'm going to deploy it. A particular way we need to select, and I need to select the respective parameters. And then deploy VNF. And once I'm going to deploy, as soon as like it start the deploying, means it will now create different virtual machine for me. A respective virtual machine for MME, it create one virtual machine. For HSS, it create one virtual machine. For S gateway, for P gateway, and for PCRF. These all functions to be generated on the virtual machine with their respective interfaces. Like MME VM will be connect to HSS VM using S6A interface. Similarly, MME will connect to S gateway using S11 interface. S gateway will connect to P gateway using S5 interface. So let me check with our compute and instances. So whatever instances are going to be created here is based on my package or the template that I have designed. So here you can see it's all building MME, PCRF, S gateway, P gateway, HSS. These all different virtual machines are about to build. And once these are spawning within 1 minute, the complete network, or you can say a complete EPC, the packet core will be on board on my cloud. And this is a real network that you can deploy, or you can have a process here. Means inside these all virtual machines, you can define their respective functionalities. Like in MME, once MME function is running, then whatever packet coming to MME will be processed here by this virtual machine. Similarly, this will transfer the message to HSS, and then it manages the mobility and session. Finally, the packet is going to be forward from S gateway to P gateway, and P gateway is connected to PCRF for all the policy charging. So here all virtual machines are up and running, and that we can see in our cloud technology scenario. So once I come to my network side and see my cloud, how this cloud is generating the connectivity or the service functional chaining in between these functions, so that we can define here. So basically for each network function, we are having SFC, service functional chaining, deployed over here using the NFV. So using these service functional chaining, end-to-end packet will be forwarded. So we can see here. So you can see here now, we are having a network. This is PCRF. PCRF is using like interface of GX and connected to P gateway. Similarly, P gateway is using S5 interface connected to S gateway. S gateway is using S11 interface connected to MME, and MME is using S6A interface and connected to HSS. So this means my complete topology, my complete like EPC environment is now activated here. And these all are real-time virtual machines that you can even launch from the console, and you can initiate the configuration. So let me launch it. So here you can see my functions is going to be connected, and once it up and ready for the launching of the OS, we can initiate any functionality here. Means on top of the console, we will be able to log in with my connection. So Ceros, like here. So you can see this is one of the Linux operating system. Okay, on top of this Linux operating system, we can run HSS server. The functionality of HSS here. We can write code, deploy here, running over here, and this will be work for my telco cloud. So this is how we are going to deploy the network function. Okay, so the end-to-end scenario is what? First, we need to develop the code. Then we need to test it using the Python code. And once we test and that is functional, then we need to check the service functional chaining, whether all the functions together working properly or not. So as like you have initiate the particular message, the network is going to be forward a packet on S1AP protocol. So how you will test here? For that, you have to deploy a complete EPC on cloud, and then you are going to check with the code that you have developed whether the packet is forwarding according to the 3GPP protocol initialization or the architecture or not. Okay, so that is the complete testing. After this, you will be allocated as a project, a practical project, a real-time project there. You have to work on project, and then once you done the project, you deploy the project, you will be able to crack the interview. So as like in other training institute, we are having like the theory sessions. They all promoting the multiple like protocol level or IMS testing. These are the theoretical session over there. But here we are more focused on the practical part. How we are writing the code for the C, for the complete like embed code, how we are going to test with the real-time scenario with the Python environment, as well as how we are using the telco cloud to deploy this. There we utilize the virtualization as well as containerization. So that is a demand of the industry, because if you know C, if you know Python, if you know OpenStack cloud, you know Linux, you know container, Kubernetes. So these are the current working environment. If you know these things, you will be able to join anywhere. So this is all from my end. That is the complete like practical scenario. For further query, you can call on the number that is provided by sir, that is 8826900552. And for the registration and for further like feedback, you can talk to 8826900551 number. Thank you.